Yeah, sure. Circle. It's a dot. Yeah, sure. It's concentric to a point. It's center. Center with radius what? Root r. Root r. Yeah. How would you do number 6? Pick values and then trace them. So how about this? You know, like pick a bunch of values and then trace what you get. 0 equals x squared plus 4y. Sketch that. 1 is equal to x squared plus 4y. Sketch that. And then when you get an idea, it might not be best. It might not be best to just increment by 1. You might want to pick good values. Pick values. So the reason I picked e to the negative r, right, is because it simplifies really nicely to that. You can pick anything you want. I mean, when we do the level curves, though, that's an arbitrary choice. So make it nice. Make it as nice as you want it to be. But yes, it is.
Not.
Oh, so concave down, you mean?
Concave, yes.
It's concave down. So you're more, I can't really, so.
You can do it in space-time.
Hold on, yeah, let me just do this. Look at the green here. So it kind of goes like this instead, right? You're saying?
Yeah.
Yeah. I got it. Now I am, yes. So yeah, it's so this is concave what?
Down.
Down. And this red right here represents the domain. The set of all input values.
So it's not inside though.
It's not inside, that's correct.
Outside.
Well, hold on. It's everything. It's the domain is everything outside. The red outside. Yes. Let's just verify this real quick. Y equals what? Y equals 2x. So that's going to be the limit as x 2x goes to 0, 0. So just so I can see this up here, it's going to be 2x times 2x all over x squared plus 2 times 2x squared. So that's going to be what? 4x squared over what? 9x squared. So that's going to be what? 4 9ths, right? 2/3 does not equal 4 9ths, so the limit does not exist. So if you're attacking one of these limits, always check a couple paths first, because if they don't agree, then the limit doesn't exist and you're done. If they always tend to agree, like if you keep on getting 0 or 1 or 1 or 1 or 0, 0, 0, try to apply the squeeze theorem.
Did we learn a different way to do that?
Yes, there are so I didn't do that partial.
Okay, well, maybe we'll do your method next. X, Y, Z. What's that going to be equal to? 2z. Okay, we did those partials. What do you want to do now?
Make it a gradient.
Okay, we can. Well, we can see the gradient vector, but what do you want to do to this one? Yeah. Well, how about we call this one gx, y, z is equal to 2x plus y minus 3z. What's gx going to be? Equals 2. What's g, y, x, y, z going to be? 1. And what's g, z of x, y, z going to be what? -3. Correct. Got that? Okay. So what does that tell us? They need to be proportional, right? In order for it to be tangent, in order to be parallel, those need to be proportional. So what's x going to be?
X is going to be 1.
Okay, what could y be? 1/2, and what could z be?
-2 over 2.
Hmm? You can change the positive and negative of what? Of x. Why? Ah, because it could be going in the opposite direction, you mean? Okay, so hold on. Before we go on to what... Hold on. One sec. Is this one of the answers? Could this be one of them? Are there others? Yes, so let's just finish where we are right now before we go off and do another method or find other answers.
I'm actually doing the right method. You're just writing it.
Write it differently? Okay, so we have that. So what other triple could we have? So we have one like this. What else could we have?
Oh, well, because there are infinite sets of numbers.
But instead of isolating lambda, let's isolate x, y, and z. If we isolate x, y, and z, we have x is equal to lambda. We have y is equal to lambda over 2. And we have z is equal to -3 over 2 lambda, right? What can we do with all three of these? Plug them in right here. This is something we haven't done before, but you definitely can.
I think that's better.
I like this because it gets us there a little faster. I understand what you meant by cross multiplying and substituting, but if we do this, you end up with lambda squared plus lambda over 2 squared plus -3 over 2 lambda squared is equal to 1. So you end up with 1 plus 1/4 plus 9/4 times lambda squared is equal to 1. So what is that? 14 fourths? 14 fourths, 7 halves. So lambda squared is equal to 2 sevenths. So what's lambda equal to? Plus or minus root 2 over 7. Okay, I like that. So what would you have to do now?
Oh,
Ah, so we can take this, right now we have our lambda, and do what with it? Plug it back into these, right? So what's x going to be?
X is gonna be
Plus or minus
root 2 over 7.
root 2 over 7. So if x is plus or minus root 2 over 7, what's y going to be?
Y is gonna be plus minus 1 over root 14.
No. Divided by 2, multiplying by 4. It's plus or minus root 2 over 17 all over. Oh, you simplified.
Yeah.
Thank you, I got it. Z is equal to negative 3 over 2 times...
Negative is 3 over root 14.
Yes, I haven't simplified it yet, okay? You need to slow down for 1 second. So my question is, how many points have we described?
6.
We have to be really careful. We ran into this problem before, remember?
Oh,
We described too many of them and they didn't fit, right? What do we know here? If x is negative, y is negative, right? So x and y have one sign and z has another. So how many possible answers are there? There's only 2 here, right? There's only 2. So if we simplify this a little bit, and I'll pause because you don't really care about the simplification. So what's the first thing we need to find? The partials. And that's going to be what? YZ. Yeah, I got to write all this out. It's kind of fun to write it all out in a way. No, I actually find it kind of soothing because it feels like you're doing a lot more than you actually are. You know what I mean? I don't know. Okay, so we have that, right? And then we have gx, sorry, I just got to write all this out, is equal to 2x, gy is equal to, and gz is equal to 2z. So actually write out what you know. You know that yz is equal to lambda times 2x, and you know that xz is equal to lambda times 2y, and you know that xy is equal to lambda times 2z. Now what?
You go right at the original constraint.
Yeah, don't forget the original constraint, which is x squared plus y squared plus z squared is equal to? No, it's equal to 3, I think, right? So now, this is the creative fun part where you can go in different directions. Like the last time we just solved for lambda, right? We hadn't done that before. Usually we kind of just use that as the glue to bind together to make our nice ratios. In this case, what do you want to do?
you might want to isolate the lambda since the variables are too complex.
Yeah, it's really going to be challenging to find some sort of nice like looped triangle. I would go for lambda right here. I think that's a very good thing to do. So with lambda is equal to yz over 2x, and you get lambda is equal to xz over 2y, and you get lambda is equal to xy over what? 2z. Now here's the thing, if we had tried to do what we did before, or what Danny wanted to do originally, isolating x, isolating y, and isolating z, it doesn't really help you too much. Jerry, careful. So now what do you want to do? Set them equal to each other, is that what you said? So we'll call this the first one, the second one, and the third one. Which ones do you want to set equal to each other? 1 and 2? So we get yz over 2x is equal to what? xz over 2y. So what do you end up with? 2y squared z is equal to what? 2x squared z. What cancels? The 2's and the z's cancel, so you're left with what? Is equal to x squared. That's kind of cool. Now if we set, you want to set 2 and 3 equal to each other?
Can we say x and y equals to each other?
Well, hold on. Let's just stop there for a second, okay? Let's just pause there for 1 second and see if we can get one more thing. xz over 2y. I'm setting 2 and 3 equal to each other. xy over 2z. What are we going to get? 2x squared is equal to 2x y squared. What cancels?
Everything except for x, y squared and z squared.
So we know that z squared is equal to...
So g squared also.
Hold on, I understand. X squared, y squared is equal to z squared, and y squared... Yes, I understand it. So therefore, what do we know?
We know that
X squared is equal to
1.
z squared, right? I'm just writing down everything we know. It's very rare that you're going to be doing a math problem. You're just going to figure out exactly what you need to know for the next step. Sometimes you're going to find out too much, That's okay. Sometimes you're going to figure too little and you need to figure out some more. But look at our constraint here. We want x squared plus y squared plus z squared is equal to 3. So what can we say? 3x squared is equal to 3. So x squared is equal to? Yeah, so x is equal to plus or minus 1. So how many points do we actually have here? I think we have 8 of them, right? Because it's x squared equals, we got this. X squared equals y squared is equal to z squared. Yeah, so we have plus or minus 1, all of these, and plus or minus 1. There it is.
Wait, so we have a
Ah, so how do you maximize this? What are we trying to maximize? X times y times z, right?
so you want to make it positive.
We're trying to maximize x times y times z. This is similar to one we did yesterday, I think. So if we want it positive, the max is going to be, what is it, x, y, z. So the max will be when it's 1.
Or
Wait, did that-
Shh. Do not talk over each other. 1, 1, 1. Is that one of the maximums? Yes. What else?
Negative, positive.
Yeah, negative 1, positive 1. Negative 1, positive 1, negative 1, or...
Positive, negative.
Yes, exactly. 2 of them are negative or all of them are negative, right? And then the minimums are going to occur at all the other ones. Negative 1, negative 1, negative 1. 1, 1, negative 1. 1, negative 1, 1. And negative 1, 1, 1. Great. All of these come out to be 1. All of these come out to be negative 1. Yay. Very cool. That last step is important because you need to actually answer the question that's being asked, which is what you're saying, which is... Okay, so look. Do you understand how we got to here? To these two equations? You're good with this?
I don't understand why 0
Got it.
is there.
Okay, if y is 0 and x is 0, they both are equal to 0, correct?
Yes.
That's all we're saying.
Okay.
That's all we're
Okay,
saying at this
okay.
point, okay?
That's
That's all we're
fine.
saying. So, Ningy,
That's
go
fine.
ahead.
Could it be anything on the y-axis?
There could be more. Hold on. If y is 0, it turns both of them into 0, right? Just because we said 0, 0 was one of these critical values doesn't mean that it's the only one.
I was throwing up that.
Hold on. Does it mean it's the only one?
No.
No, it does not. If y is 0, what can x be?
Anything.
X can be all real numbers. Anything, right? It can be totally anything. So what is that? If y is 0 and x is...
Since XX, wait.
It is when y is 0 and x can be... That is the x-axis. Okay, got it. Now, that's by deduction, right? But also what could be true? 4 minus 2x minus y could be 0. And what else could be 0?
8 minus 2x minus 0. Okay. Yes.
And this right here, hold on, and this right here, if we satisfy both of these at the same time, could this be another solution set?
Yes.
Absolutely. So in this case, what class are we now in?
Algebra 2.
Substitution.
Substitution, algebra 2. Thank you. Harmony, very good. Good job. So y in this case is equal to 4 minus 2x. We jack that. No, y is equal to 4. I just move the y to the other side. We jack that in. We get 8 minus 2x minus 3 times 4 minus 2x equals 0. So we get 8 minus 2x. I know there's a lot of ways. You guys remember, you're super special and you're awesome. I got it. You're awesome.
I know what it was.
Why are we subtracting 0?
Because I'm feeling like it, okay? You get negative 4. Am I okay so far?
I'm confused about why we're subtracting 0.
Okay.
Why are we
don't
subtracting?
like it.
What am I subtracting 0? Where's 0?
It's an equal sign.
Oh, okay, that's fine.
What's wrong?
Second to the bottom line.
What did I
should be an
do?
equal sign.
Yes,
Sorry.
it's skipped over. It's okay. Equals what? Is that okay? So what does x equal?
1.
1. So if x is equal to 1, what's y equal to? Because of this, you know it's equal to 2, right? So what do we have now? So far we have the x-axis and what else? This one
Y-axis.
point.
And the y-axis.
And the y-axis?
No.
Because right there.
Really?
Second equation that we solved, if x.
This one right here? You mean that one right there? Yes, if x is 0. But look, if x
But
is
it doesn't
0, but look,
satisfy the first one.
if x is 0 here, yes, it makes the whole thing 0. That's correct. But does it satisfy this one?
No.
No, it doesn't. If x is 0 right here, what does y have to be?
4. 4 and 0.
So you're right. If x is 0 is also one of them. We can do that one separately right here. If x is 0, that satisfies the second line right there. I totally agree. But we need to satisfy the first line as well, right? So that has to be y squared times 4 minus y is equal to 0. So y is going to be what? 0 or 4. We already had that because we had the x-axis right here. So what point did we add in? 0 what? 0, 4. So we have 0, 4, the x-axis, and what point? I'll highlight these. And what? 1, 2. So we have 1, 2, the x-axis, and 0, 4. We have 0, 4. Now, what do we have to think about?
The edges.
The edges. We have to think about the edges of this, right? And luckily, how many edges? We don't have 4 edges. We have 3 of them, right? So what do we have here? We have, let's just look at this from a down perspective. What were the 3 coordinates? 0, 0?
0, 6, 6, 0.
Oh, nice. Okay, so we have 0, 0, 0, 6, and where else?
6, 0.
6, 0. And what have we had so far? We have, this is our region, right? It's the inside this, right? It's inside it. So what points do we have here? We had the x-axis.
Yep. 1, 2.
1, 2, and where else?
0, 4.
0, 4.
Check that, please.
You only have one critical point.
Hold on. So 0, 0, 1, 2. So like right about there. And the
0, 0.
x-axis. So we think something interesting happens there. That's nice. Great. What do we do now?
We find the critical point that belongs to B.
Wait, didn't we just find the critical points?
No, because
Equals what?
0.
Equals 0. So 6y times y minus equals what? 0. So y is equal to 0 or y is equal to, or that's where these critical values occur, right? How do you prove which one's a min and a max?
Second derivative.
Do a second derivative test. I can, that's fine. F double prime of y is equal to negative 24 plus 12y. F double prime of 0 is 24, which is less than 0, so it's a max, right? F double prime of 4 is going to be negative 24 plus 48, which is 24, which is greater than 0. Smiley face means a minimum, right? So then you take these values and you plug them back into where?
The original.
The original, but what else do we need now? We also need the,
Points.
we need the x value because we're plugging in x and y back into our original equation. And what did we have that line? It was what y is equal to, x is equal to what? 6 minus y, right? X is equal to 6 minus y. So in this case we had the equation, so we know we have the 2 points, 6, 0, and we have the points what? 2, 4? Thank you. 2, 4. And what do we have to do with those 2 points? Plug them into the original equation, right? Which was, let me go back all the way up here to this one, right?
Yep.
Copy. Nice. Well, one of them has a 0 in it, and do we like that?
Yeah.
Yeah, so we know that f of 6, 0 is what? 0 minus 0. F of 2, 4, it's going to be 4 times 2 times 16 minus 4 times 16 minus 2 times 64. Did I do that? Please tell me. Thank you. It's minus, what's negative? That's where? It's y cubed, right? We're plugging in 4. Oh, it equals negative 64? Thank you. Thank you. Nice. Okay, so have we figured out what the minimum is now?
Yes.
What's the min value?
Negative 64.
64. And the max is going to be?
4.
4. Nice.
That was
Mr.
fun.
Seamon, do we need to check the end point on that edge?